The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hello, everyone, and welcome. This is the end of Advent of Code 2023. We finished all the problems, and we are going to tell you all about it. How are you doing, David?
That's right. I'm doing very well. I haven't had a chance to work on the finals problem. And to be honest, I did think about it, but I was pretty stumped anyway. So it sounds like you managed to get the answer. So congratulations, Leandro. That is awesome. And I can't wait to see your solution.
All right, what a ride it has been. And look at that, we have the star for day 24. Isn't that beautiful? We still don't have a star for day 25. We have to...
Could you share your screen with me?
Oh.
Sorry, my bad.
One day, I am doing it now. There. So we have the star for day 24, and we just have to press the big red button for day 25, but I saved that for us to do together. So let me tell you a story of day 24, part 2. Just as a quick recap, hailstones are moving on a three-dimensional space. We have to be in a certain place and throw a rock in a certain velocity so that we'll hit every hailstone along the way.
Yeah.
And we talked about different approaches to solve this. And I was thinking of one approach in which you would think of the problem not from like space perspective, but from a time perspective. So you would plot the time axis versus a position in one of the three axes. So you would do time versus X position, times versus Y position, time versus Z position. And then you would try to cross the information from the three graphs, particularly looking at the order in which you hit the hailstones. And then I showed you graphs that look like these. So for the given example, these lines are the plot of time versus position on the x-axis, y-axis, z-axis, and each of these lines are one of the hailstones, and the dotted black line is the rock for the given answer. And in this case, we hit purple, then blue, then green, then red, then orange. And in here, we also hit purple, then blue, then red, then green, then orange. We are actually on top of the red line, so we can hit it at any time. And on this one, same. Purple, blue, green, red, and orange. Then not only... Yeah, I'm still like that. Not only we are hitting them in the same order, but we are hitting them at the same time. So for instance, here we hit purple at 2. Here we hit purple at 2 as well. And I implemented this idea. And guess what? For the small example, I was able to do some work with the constraints. But for the big example, it was too slow because there were too many constraints. And then I was like, okay, back to the drawing board. So I came up with another idea. And it goes like this.
Yeah.
If you want to hit this hailstone, then you can either hit it from below, and if you hit it from below, you will have to have initial position that is less than this one, but it needs to have an angle or a velocity that is greater than this one. So we are looking at a line that has a velocity of -2. This needs to be -1 or greater. And then we hit the hailstone at some point.
By hit it from below, you mean like anywhere on that region, I suppose?
Yeah, no, I mean, in the x-axis, this is the x-axis. From hitting it from below, I mean like I'm approaching it from one of the sides of the x-axis, specifically the left side of the x-axis.
Yeah.
Or I can be exactly...
Wait, isn't that the y-axis?
Huh?
Do you mean the y-axis?
No, I mean the x-axis. This is a plot of time versus x.
Oh yeah, I forgot about that. Okay,
Yeah,
that's
I guess I
confusing.
can label the y-axis as time, and this is the y-axis. This is the x-axis, and this is time. And when I say x-axis, I mean with respect to the original coordinates of the hailstone.
Yeah,
So I can either hit it from below with velocity that is greater than the hailstone. In other words, I am behind the hailstone, but I am faster than it, so I'll reach up to it at some point. Or I can start at the same point with the same velocity, so in this axis, I'm traveling with the hailstone, which makes it easy
yeah.
to hit it. Or it can be above with a lower velocity, and I will hit it at some point. So,
Well, if you're traveling at the same, yeah, okay, yeah,
and in fact, that does happen in this axis, where we are traveling along with the hailstone in this axis, in the y-axis. So, with that idea, we can start with a potential hailstone that is actually not one a potential rock. A potential rock that is not just one rock, but a set of rocks. A set of rocks that is anything in the rocks have a position and velocity. So anything that has a position below, in this case, below 19, so 18 or below, and a velocity of 1 or -1 and above. So anything like this will hit this hailstone. Or
okay,
I can be at 19 with exactly -2, or I can be above 20 inclusive, and above with a velocity of -3 or below. So I constrained the set of possible rocks. And then I constrain the set further by looking at the y-axis, and I constrain the set further by looking at the z-axis. Not only that, but I also keep track of the times. So if I want to hit...
what are A and B here, and are they the same? Are you really constraining them when you look at? Is B has to be the same?
Well, we are
B is
constraining in the
velocity.
sense that it's no longer a possibility that we have an A of 21 and a B of 3, because then the intersection point would be in the past.
Oh, that's true.
So we are making the set of possible rocks smaller as we go. And we also look at the...
Just to remind me, is B velocity here?
Yes.
Maybe we should call it V then. But an A is starting position.
Yes.
Okay. And then the velocity has to be common across each of the X, Y, and Z
Yes.
graphs. So we constrain that, I guess.
Yes. So we... And then if you do this thing, you will end up constraining the set of possible rocks in kind of a clever way, which I don't have a drawing for. But if you think of the x-axis as, let's say, position, and the y-axis as velocity, what we end up doing with this is that we end up with like these rectangles, like let's say a rectangle that I'm describing with my cursor here, and then some dots as well. But you end up constraining this further and further. And my hope was that in the end, you would end up with a single point in each of the 3 graphs for the 3 axes.
Yeah.
As it turns out, I implemented that, and guess what? It kind of works in the smaller example, but it doesn't scale for the bigger one because we have too many of these regions to deal with. And at that point, I was like, oh, shucks. So I did the thing that I did not want to do. And I'll let you know, this was like a lot of time. I spent like probably 30 hours on this problem already. I was descending into madness, and I was traveling, and all I could see was hailstones and rocks. On New Year's Eve, I went to a concert, and there were those spotlights that traced lines in the space, and I was like, oh, these are like the hailstones. How can I compute their intersection? Yeah,
Wow, officially nerd Snoke.
yeah,
Yeah.
like going crazy. Uh, anyway, I did what I didn't want to do, and I went online and I looked at some hints. Specifically,
Uh,
I looked at one hint that unlocked the thing for me. The hint was look at the problem from the perspective of the rock that you're throwing. So now the rock, imagine it's big enough that you can stand on. So from your perspective, the rock it's not moving. The rock is stationary. It's like you are on top of a rock right now, and if you look up on space, you are moving very fast, but you don't see the movement. You see the stars moving. You don't feel the movement, right? Because you're on top of a rock right now. It's called Earth. So think of the problem from the perspective of the rock. And what is interesting about doing it that way is that you no longer have to think about position and velocity of the rock, because there is no velocity to the rock. The rock is stationary. The velocity of the rock is zero from your perspective, from your point of view. That makes the problem kind of interesting. How do we plot? So forget about these plots of time versus axis, okay? Just think about a plot that we did for part 1, which is simply trace the paths that the hailstones will describe on the XY space or XY plane. So forget about Z, just think about how the rocks are gonna navigate on this XY space. And by the way, as an aside, I also plotted the rocks themselves. So here you have a slider for the time. The rock is this gray thing.
That's so cool.
And then as you progress, you see the rock hitting all the hailstones, for the example. Isn't that cool?
That is so cool.
Yeah. So you end up with a graph that looks like this.
How have you plotted that? That looks really cool.
Yeah.
Just that E1.
You can always plot, first of all, there is a Desmos 3D. You have to go to that. Then you can plot any point on a three-dimensional space by giving its coordinates. Like I can plot a point called like 2, 2, 2. It's this point right there. But you can also make it parametric with respect to t. And
what is T at this point?
t is this, it's the time, and it's this slider.
Oh, you created T. That's really nice. Yeah.
Yeah. And these equations, you will see a similarity between them and the input data. 19 minus 2, 19 minus 2. So it's just the 3 coordinates and initial position and velocity. So this is the plot for part 1, okay? What I did here is simply take the numbers from the hailstones and I plotted them, and we are looking at the intersections. So forget about this part. Oh, hello, Bo. Bo says that he's lurking on the stream. Thanks for joining us. So this is just a drawing of the part 1 and all the intersections that happen. And this is from the perspective of you standing still on the origin of the graph. But now let's shift this perspective so that we are looking at it from the perspective of the rock that we are about to throw. How do we do that? Well, the rock is it's not moving. What is moving is everything else. So think of like if you are standing on the side of the road and a car passes by at 100 kilometers per hour. You see the speed.
Sorry, can you just explain the equations that we have on the left? I'm a bit lost as to what I'm
These
looking
equations here? It was me essentially getting. Remember that we implemented part 1 using some ways to transform the position and velocity into slope and initial y. Yeah, so I plotted that. I used that here.
Got it. Okay, and so you plotted these lines for on the XY plane, so this is 2D,
Yeah.
and
And these are the regions of interest for part 1. This essentially plots the solution for part 1.
okay, cool, I'm with you.
So now imagine that you are on the side of the road and you see a car passing at 100 kilometers per hour. You see it at 100 kilometers per hour. But now I'm shifting the perspective. Now I am inside another car that is going along the first car at, let's say, 75 kilometers per hour. Then from your perspective, you don't see the car going at 100. You see it as if it was going at 25 kilometers per hour because you yourself are going at 75, right? So what you see, the perceived velocity, is the difference between your velocities. Does that make sense?
Yeah.
Okay.
Yeah.
So as it turns out, in these equations here, the velocities end up being here, the velocities for the x and y axis. So what we have to do to shift our perspective is to subtract the velocity of the rock, which in the given example, we know it's like -3 and 1 or something like that. And if you do that, you end up with this graph, which is the same as the previous one, but minus the velocity of the rock here. And look at that. The intersections, they all collide in the same point. Well, that makes sense. Not only they collapse at the same, they intersect at the same point, but this is the point where the rock needs to be to begin with. This, if you look at the given answer for the example input in Advent of Code, you will see that this is the initial position of the rock. And when you think about it, it makes perfect sense. Because when we shifted our perspective to be on the rock, what we see is we are not moving, we are stationary, and every hailstone is moving toward us, because at some point the hailstones are going to hit us. So it makes sense that all the trajectories need to intersect in the same point, that point being us. And we are in this initial point. Isn't that crazy?
What did you subtract, actually?
So
The velocity of...
I got the example answer, which is here. So the rock for the given example starts in this position and has this velocity. So the position we don't care about. In fact, we are trying to find it out. But the velocity is this. So I just added, or in this case subtracted, in fact. So minus 3 is actually +3 and -1 on the top. And the places here in this equation just fall out from the thing that we did on part 1.
So you subtract... Yeah, I forgot that it had an initial velocity. Okay, so you subtract the velocity of the rock.
Yeah.
To get this A position.
Yeah. And the velocity of the rock actually appears twice in the equation. It appears here and it appears there.
Yeah, my brain is trying to understand how that kind of reverses things, because it actually starts in a position. If you have in the previous graph, it has a start position as well, right?
Yeah.
Which one is the rock in this?
It's this one.
Okay. So they all have these start positions and whatever, and then because you're moving, you sort of reframe everything to work out where it actually collides. It's kind of weird. I can't see how it collides in that position at the end. Like when you compare this graph, if you put these two side by side, the transformed one and this one, yeah, I don't see quite. Like, where does the yellow graph? Where does the yellow line go?
You mean this one?
Yeah, or orange, yeah.
This one? I see it. Where is it? It is this one that is selected. Or is it? No, it's not. Where does that one go? Ah! Behind the purple.
I see.
These were rocks, these were hailstones that were on the same line, but at different initial positions, perhaps.
Okay. How did they get transformed into the same line? Different velocities or different? I'm struggling to work to grok how these lines get transformed into the second thing, or how they, because this is still in the XY plane, right? It's
Yes.
just at a different moment in time.
No, not really. We are shifting our perspective. Instead of being an external observer, stationary, now we are in a frame of reference that is moving. So
Yeah.
that affects the velocities of all the hailstones around us.
That makes sense. Are you able to even draw the rock itself in the second graph? Does it even make sense? Would
Well,
it
it's
just stay
this dot. It stays here. It
right?
stays stationary. It doesn't move. But it's there. The whole time it's just standing there in this graph.
Yeah. That makes a lot of sense. It's really crazy. Yeah, I'm starting to make sense in my head.
Yeah, you are in
Yeah.
this rock spaceship, and it's an unlucky day for you because you are traveling through space, and all you see is like hailstones in your direction, and they are very particular and aimed at you.
But they don't. But they all hit at the same time, don't they?
No, they may not hit at the same time because these lines are the trajectories of the hailstones, but the actual hailstone may be like one dot that is moving toward here, and then bam, it hits. And then there is another dot that is closer by, and it hits first. And then there is this one that hits later because it's all the way back and it's moving very slowly, but at some point it will hit.
So why do we have like one particular dot as a particular? Why doesn't it move also through time?
Well, because the whole premise of this graph is that we are looking at it from the perspective of the rock, so the velocity is zero. It doesn't move. Over time, its velocity is zero, so it just stay in that position.
Why isn't it? If the velocity is zero, why isn't the xy zero?
Well, because there is only one place in the three-dimensional space, or I guess in the two-dimensional space, there is only one place where the magic happens, where all the lines will intersect. Given the initial conditions of these hailstones, there is only one place where this will happen, and it happens to not be at the origin. The initial position of the rock needs to be here because that's where the magic happens. That's where the lines will intersect. And if you change the velocities here, there is no other velocity that will give this arrangement with a single intersection point for all lines.
Yeah.
And this is by construction.
And this represents
That's what Eric designed in the hailstones for the problem.
That makes sense. And this is the initial position, not the point where they will hit it.
Correct.
It's just the initial position. Yeah. Okay.
Yeah, this 24 and 13 here. Yeah.
Thanks for explaining. Yeah.
Okay, so what does that buy us really? What was the point of doing the transformation? Well, it is that instead of having to think about both the initial position, we had a graph for this. Instead of having to think about both the initial position and velocity of the rock, now we have to think only about the initial position, which is, in fact, what we care about, right? That's what we want to find out.
Yeah.
But to find it out, we still need to know the velocity. I plotted this 3 and minus 1 here by hand, right? How do we find this part? How do we find this initial velocity that is going to make the magic happen? That's kind of crazy, right? Well, that velocity happens to be small enough that you can brute force it. You can
You don't need the velocity, do you?
You need the velocity
But
to determine that you found this magic situation.
Yeah.
right? Once you have the magic situation, you have the initial position of the rock, but you have to find this situation. So how do you do that? Well, you brute force it. So you think of the velocity as like, what if the velocity is 0 and 0? What if it's 0 and 1? What if it's 1 and 0? What if it's minus 1 and 1? What if it's 2 and 1? What if it's 1 and 2? You think of all the possible velocities, and as it turns out, by construction of this puzzle, the velocity is small enough that you can brute force that.
Yeah, that's true.
And it could not be the case, by the way. It could not be the case, because in the real inputs, we see some large numbers here, and that means that the rock could need to be very fast to hit all of that. So the velocity could be large, but it so happens that it doesn't have to be that large. So you can brute force that. So all you gotta do is find a way to enumerate all the possibilities of pairs of x, y, including negative numbers. Then you can try and see if you got this magic situation. And then if you did, you will find the x and y coordinates for the initial rock, for the initial position of the rock. Great. And from that, algebraically, you can determine the z position as well, because you can determine, given an initial position and a velocity that you guessed right, then you can determine, for instance, when did it hit the red hailstone? Oh, it hit at time 3. And when did it hit the blue hailstone? Oh, it hit at time 5. Okay, so given the hits at times 3 and 5, you can work out the z coordinate of the rock.
Nice. So I guess you didn't necessarily need to. If you had like believed in principle, all you have to do is subtract the velocities and the initial coordinate will fall out, then all you need to do is just do that for x, y, and z, and then you don't need to work out the velocity.
Well, the problem in doing that is that the brute force for x, y, and z takes a lot longer, because we will be testing the same x and y with different z's, and the x and y already does the magic for you. So you can do that, but I'm not sure if you brute force that it would be feasible computationally.
No, I mean I don't know brute forcing. Isn't all you have to do just subtract the. Oh, you don't know the velocity.
Yeah, you're guessing the velocity by brute forcing it.
Yeah. Oh, I see. Wow, okay, got it. Yeah.
In summary, this problem is like 1 order of magnitude harder than every other problem is solved, including the problem that I said was absolutely hard, which was day 8.
Yeah.
But it's a very satisfying problem when you can work things out. But that's not the end of the story. That's not the end of story.
Okay.
Because, David, I will let you know that if you implement what I just described, it works for the example inputs and it does not work for the real inputs. And then it was like taking its sweet time, and I was like, okay, so maybe it just takes longer to find the intersection of all the hailstones. And after 1 hour or 2, I thought, it's taking very long. The velocities were not supposed to be that large. These numbers are big. I think I'm running into problems with floating point precision. When I start using these numbers and multiply them and add them together and all of that, you start losing precision in floating point numbers. And if you test for equality, for instance, it will not work, because then the number will be ever so slightly off. So I changed the comparison to do this, where I subtract the numbers and I check against a delta. Are the numbers different enough?
Oh, wow. I thought you were going to use big N.
I could have, but I thought that was going to be slow. And I was already running into what I thought were performance issues. So I did this. And I also did another little trick, which is to offset. So I start by offsetting the whole problem closer to the origin by simply subtracting the positions, or subtracting an offset from the positions. And then at the end, I resolve the problem as if the problem was translated into the origin. And then I multiply by the offset, or I add offset times 3 to offset it back. Oh, hello, Nod was one. So this helps because the numbers become a bit smaller, but they are still kind of large. If you look at some of these these coordinates, for instance, this is at 3 and this is at 4. So this is going to be a large space still. So there are still some floating point problems here. So translating helps, using deltas helps, but it doesn't go all the way there. There are still some like floating point precision problems going about. And maybe I could work out some clever solution for this. But then, I'm not gonna lie, I looked for another hint. And the hint is that this is a very magical situation. The name of the puzzle is Never Tell Me the Odds. As it turns out, the problem has been massively overspecified. If you have 3 rocks, or 3 hailstones, that are not linearly dependent, that are not like on the same line, let's say. If you have 3 rocks that are, or 3 hailstones that are not magically aligned, they already define a unique solution to the problem. So instead of running with all the inputs, you can run with just 3 lines. I got the first 3 lines. And then once you do all of that combined and run it, it turns out to be very fast. And this is the right answer.
Wow, that's really cool.
So that was a journey. And
Wow, congrats, man. That's really hardcore. Don't know if I'd ever have got there in the end.
it was very satisfying. And I finished this yesterday afternoon when I sent you that message.
Amazing.
Yeah, so all of this combined, I was like, oh, this is really complicated. I mean, this is just parsing. But here, I do the velocity search and I have to come up with ways to compute every possible velocity because I am brute forcing. So I had to come up with this little idea of how to enumerate all the coordinates. That's what this quadrant is all about. And then I have to check for the intersections. And some of them may be parallel, so they become not a number because I divide infinity by infinity. And then there is all this arithmetic to compute their intersection with as few operations as possible because I thought that I had a performance problem. And I also have to subtract the rock velocity, so I have to do that. And then once I have the x and y solution, I still have to compute the z solution. So I have to do a bunch more arithmetic to get the times, and I have to do a bunch more to get the positions, and all of that. All of this is very complicated. And I started looking at other people's solutions. And as it turns out, there are many ways of going about this, which is another very satisfying part of this problem. You can think of this problem as a set of equations and try to solve this set of equations. And the sets of equations, I will paste this into a separate buffer so I don't spoil the rest. So if you look at the 3 hailstones that actually matter, the 3 that will determine the solution, and the rock, then you can write equations like this that are fairly straightforward. You will say that the initial position of the rock on the hailstone on the x-axis plus its velocity times a given time t1. We don't know what t1 is, but it's the time when the rock is going to hit the hailstone. Well, this computes the position of the hailstone, and this computes similarly the position of the rock. So this is the initial position of the rock on the x-axis. Here I forgot to replace one variable. This is the initial velocity of the rock, and this is the time of the collision. The same for the y and z axis. And then you do that for for hailstone 2 and hailstone 3, and you end up with this lovely set of 9 equations. Some of the numbers we know. These numbers we know. Some of the numbers we don't know. These numbers we don't know. More to the point, we know all of those. We know this 3, 6 by 3. We know these 18 numbers. We do not know these 6 numbers. And we do not know
Yeah.
these 3 numbers either. In other words, we don't know 9 numbers, and we have 9 equations. That's a good thing. We have the same number of equations as we have of variables.
Sounds like you could solve this without a computer.
Yes, you can. But you have to do some work because these equations are non-linear equations because 2 of the unknowns are multiplied. So if you want to solve this by hand, you have to massage these formulas so that these multiplications become additions. And then it becomes a linear system that we know how to solve fairly straightforwardly. There is a technique called Gaussian elimination for solving linear equations that is easy enough to implement that I implemented as an undergrad, but hard enough that it took me like weeks when I was an undergrad.
Yeah.
But we know how to solve linear equations very well. So there is a way to transform these equations into a set of 6 equations with 6 unknowns, and they are linear. Specifically, the massage that you do has to do with like finding terms that are in common, and then you subtract lines of equations and stuff like that. There is more detail in the subreddit, but I don't remember the details all that well. But there is also the cheat mode way of solving this, which is to take this set of equations, populate with your numbers for your inputs, and throw them in an equation solver. You can throw this in MATLAB, you can throw this in Mathematica, you can throw this in an equation solver, and it will spit out the answer.
Wolfram Alpha does it?
Wolfram Alpha does it as well. I'm not sure if it does for the non-linear version or if you have to linearize it by hand, but some people said that they used Wolfram Alpha.
Okay.
Wolfram Alpha may only able to do it with linear equations. But there is this equation solver that everyone used, or that most people used, for people who ended up using these kinds of equation solvers. And in fact, it was interesting because when I was thinking about my first thought of looking at the times of collisions and constraints, and this collision must happen, like for instance, if your hailstones go like that and your rock goes like this, then the collisions on blue need to happen before red and all of that. I was thinking of representing this as a set of constraints and using constraint solving to solve this problem, right? And I implemented my own little constraint solver by hand, which did a lot of work, not optimized at all, and that's why it was too slow. But when I was in grad school, I used a constraint solver before, like industry-grade constraint solver, and that was the constraint solver that everyone used. It's called Z3. It's developed by Microsoft Research.
Oh.
And what I did not know about Z3 is that it can simply solve nonlinear equations for you. So this is solution number 2 using Z3 in JavaScript. There are also Python bindings, which are probably even more ergonomic because of operator overloading. There are bindings in every language. Z3 is a very fast equation solver. It's much more than that. If you look into it, you will see that it's actually able to solve other kinds of problems besides equations. It can solve Boolean satisfiability and so on. But for our example, we came up with these sets of equations. I instantiated the variables with my numbers. I didn't bother with parsing from this format. Then I created a bunch of symbolic variables, so I don't know what the values are.
Yeah.
Then I told Z3, can you please solve these equations for me? This is me writing these equations in a format that JavaScript recognizes. And that's the part that in Python with operator overloading, it will look much nicer. And operator overloading is coming to JavaScript in the future. There is a proposal, but it isn't there yet. So this is what we have. And then can you please evaluate the addition? I didn't even ask for the values. I already asked for the addition because that's what we need to output in the end, right? In Advent of Code. And then can you please just do that for me? So this is the solution, the whole thing. a bunch of variable
Wow.
definitions, and then just input the equations, ask for their answer, and that also runs very fast. Oh,
Can I see the?
in fact,
the
it ran so fast that
quantitative-
this was the one that I ran before. I ran the wrong one. So this was me with my handwritten solution, and this is the version with SMT solver.
Ah, it looks like yours is faster.
Yes, yeah, mine is a bit faster because it's doing the work in the 2 dimensions first.
Can I see the definition, the comment next to the definition? I just want to see how you've. Do you do T3 multiplied? Yeah.
Yeah,
So-
I sort of inverted it because these are numbers and this is one of the symbolic variables. So I did T1 multiplied by H1Vx, then add H1Px. That needs to be equal to EQ. And then the other side, T1 multiplied by RVx plus RPx.
And what does it output? Just outputs like T1, T2, but just T1, T2, T3?
You could ask for that, but I asked, can you please add these 3 variables for me and give me that? Because in the end,
Nice.
that's what we need to input.
That's really cool.
Yep. So some would say that this is cheating because you're not doing the hard work yourself. Some would say that this is the smart thing to do. But it was very cool. It was very
Yeah.
cool.
Very cool. I mean, to jump to this solution, yeah, it's really, really cool.
All right. So with all that, we have day 24. And we are able to go to day 25. And you have enough stars to push the big red button. Do you want to push it?
Go ahead. Hey!
And that's the end, everybody.
My God, that was tough. That was not easy. How many people actually managed to do this if you go to the leaderboard?
I don't know, but let's see what they say. You supply all 50 stars and restart global snow production. Woohoo! Are you getting snow there?
Yesterday we did actually. Not as nice as that snow, but
As you reach the edge of Snow Island, you can already tell from way up here that everyone will have a white Christmas this year after all. I did not. It was not snowing in Paris. Ooh, and this animation is laggy. Or is it the animation?
yeah.
It appears to be the animation. Congratulations, you finished every puzzle in Advent of Code 2023. Congratulations indeed. I hope that you
Wow.
had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via the website. If you'd like to see more things and consider supporting, to hear about future projects, I've highlighted the Easter eggs in each puzzle, just in case you missed any. Hover your mouse over them and the Easter egg will appear. Yep, just like that. That's at least one of the descriptions for each day. Oh, so let's see. Let's go to day 24. Due to probably magical inertia. What? You've never studied probably magical physics? Ah, okay. It's just like cutesy stuff in the story.
Also, there were. So it's just that they weren't highlighted, but these titles existed everywhere before.
Mm-hmm. And here is the snow
I see.
in the bottom.
Very nice. Oh yeah, it's working. I still don't understand the numbering system, the ordering, but
Oh, it's because on the story we were going up different islands and then we came back.
oh, I see. So it's actually on the physical map. I see. That's cool.
These animations are lagging my browser, or something else is lagging my browser like crazy, so I'm going to close this tab. But that's not all, David. I have more stories to tell.
Okay.
So, oh geez, it's my computer that is lagging, it was not that tab. Oh well.
Might be all your 3D animations.
Yeah, I will. It happens more when my cursor is on my built-in display as compared to the external display. Isn't that interesting? There, that should do it. No, it did not.
I can't tell it's lagging, by the way. So if you can deal with it,
Okay,
it's okay.
it's okay. So there was also day 23. And day 23 was the day that you solved, the day in which you have a maze and you want to take the longest path in the maze.
Yeah.
And we solved it, but we were not like, what's going on with this solution? Why does it work?
Yeah.
So I looked more into that. What I learned is, first of all, there is no smart solution to it because the problem really is NP complete. The only thing you can do is brute force it. And
Yeah.
the trick is that you can do the collapsing of the paths so that only the intersections or the junction points are in the graph to speed up the computation, but it is an NP complete. There is nothing else you can do about it. In part 1, there was something you could do that was smarter because in part 1, given the arrows, the graph was directed. But in part 2, that's exactly the difference. The graph is undirected. So brute force it is. It's an NP complete problem. Okay. And I wanted to implement that because I thought it was a fun little thing to do. And also because you said something kind of in passing in one of the streams that I wanted to look more into. What you said was related to the way that we put things on sets, for instance. So in day 23, we have to do the sets of coordinates, for instance. And I don't know how you did that, but maybe you did it in a way that I was doing it in many days. You did not do it that way. But in many days, when I needed to put things on sets, I would JSON stringify the thing.
Yeah.
Because in JavaScript, if you look at, oh, geez, I have to really zoom in, or I can move the window, right? There. If I want to check, for instance, if 1 is equal to 1, that works. But is the list containing 1 equal to the list containing 1? This is kind of the right answer, but kind of the wrong answer. It's the right answer if you look at the two lists as two different objects by reference, but it's the wrong answer if you look at the two lists as containing the same elements by value. And in the past, when I had this problem, I developed a little library that creates a new notion of maps and sets that does not use the triple equals equality to compare its elements. And you told me, oh, I kind of solved the same problem from the other side, from the other perspective. Instead of creating these two objects to begin with, I deduplicate them. I write some magic such that this magic is equal to the same magic again.
Yeah.
And I was like, ooh, that's an even better idea. Because then not only I solved the problem for maps and sets, but also for plain old equality, which comes in handy in many algorithms. In fact, in day 23, it does come in handy. JSON stringify can be this magic, because the JSON stringification of the lists will be the same. As long as the lists don't contain cycles and the objects define their fields in the same order, blah, blah, blah. But for most cases, it works. And if you want to keep not only the object, but also its string representation, then you have to juggle these two things in a map. Gets really complex. Or you want to JSON parse the thing that you stringified before. It's a whole mess. So I implemented my version of what you described. And
oh, that's cool.
I want to show you that because I thought it was really cool and it taught me some things that I didn't know about JavaScript.
That's really awesome because I also implemented this as a generic util. And it's actually very useful in general for like immutability, and I'm very curious about how you did this because it took me a while to get a good implementation as well.
It took me a while as well, even though it's a short implementation, because I wanted to use some features that I didn't know about, and you tend not to use them in JavaScript. So I thought it was a cool exercise. So
Wow, this is amazing documentation.
so yeah, speaking of documentation, one of the things you talked about before we started the stream today was that you were thinking about the problem of duplication and how you write documentation here in JavaScript because you want to be able to, when using the function, you want to be able to provide the kind of help you get if you hover over. So for instance, I called this function $, on the way in. I imported it as $. So if you put your cursor here, you want to have this documentation available to use. So you want to write it as a JavaScript doc or a JS doc. But it would be awfully handy if it was on the README as well. And then what do? Do you copy and paste? That's annoying. So I wrote a little project that, given TypeScript file, it will parse the TypeScript, it will find the JS docs, and it will spit out a Markdown for you. And there are plenty of solutions in this space, but none of them do exactly in this very simple way and include the types.
And can you execute them?
That would be the next step. No. So currently, I only have a way of deduplicating from the JS doc to the Markdown. Oh, hello, Fotis. And it spits out in a format that I love, which is the format for like the type of the function. And if you look at the other tools in this space, they will always try and parse the type and print it in a specific way. No, this is just literally what you would see in the type specification file, in the .d.ts file. And then it spits out the Markdown that you put in the file to begin with. This is just the JS doc. And it is true that this
That's pretty cool.
that I wrote in the JS doc is very similar to what I wrote in my tests. So it would be great if I could run the JS docs, or if I could import the tests into the JS docs, one of the two.
The difficulty with that later on, I mean, I'm sure there will be lots of caveats, but one is that you might need to have some setup code, and you want to hide that from the JS doc, but you want to show it, but you'll need it in the test, and there's like some, yeah, I don't know.
And even the way that I write things, I think, is different, and it makes sense. When I'm writing the documentation, I want to write it in this way. And when I'm writing the tests, I'm writing it this way. So there is like a little bit of dissonance, but that's minor. So it's like a future step, and it's something that exists in Python, right? The executable Python docs.
Right.
So yeah, something to look into. But okay, let's get into the implementation of this guy, because I thought it was super interesting.
Yeah.
So I call it intern because in computer science, fancy terms, that's what we are doing. We are interning the object or interning the array. And that's what the JavaScript engine does to numbers. That's why 1 = 1 works out of the box. It has this pool of values, and when you say the number 1, it reaches into that pool and gets it from there. So reference equality works. And
sorry, say that again. Intern. I mean, yeah. What's the naming? Where does it come from? The word intern.
It means that you are taking a value that would be on the heap, let's say, and it's putting inside an intern pool of objects, a pool of objects that are internal to the runtime. So perhaps the most...
Right, so like each time you create a string, it goes into the pool rather than...
Yes, that is what... Besides numbers, I think that mostly the most interesting example is strings, because in many languages, if you do this, it will say false. For instance, Java. And I think Ruby as well, probably, maybe, I don't know. But the point is that these two strings, in some languages, are different objects because they are mutable. you could say something like, if my string is ABC, you could say something like position 1, which is the letter B, change that into a Z. And in JavaScript, that does not work. Oops, that does not work. If you do this, then A is still ABC. Strings are immutable in JavaScript. And because they are immutable, then the simple equality with triple equals works.
Surprising that it doesn't throw. What if you do A1 now? Is it just because it's an object? Okay. I just wonder why that doesn't... Does it just ignore it?
Yeah, it fails silently.
Yeah.
But the way that this works is that in JavaScript, every time you say the string ABC, it's going to reach into the pool of strings that it knows, and it will reach for the same object.
Yeah.
I don't think that there is any way for you to observe this, because I don't think that there is anything that will get you the ID of the object or the address of the object in memory. But that's how things are done. And in JavaScript, it will intern all the primitives: strings, ints, big ints, symbols, booleans. I may be forgetting something. But it does not intern arrays, objects, and so on. So what the auxiliary function does here is to create its own pool of interned objects. And for the time being, I'm only interning arrays and literal objects, but in the future, I may add functionality to intern things like maps and sets as well, because maybe you want a map to be in a set, like a set of maps.
Yeah.
So maybe your map represents a graph and you would like to have a set of graphs, for instance. That could be useful. And the way that this works is simply by putting them on a list. And then when I want to look things up, I go over the list and I find an element that is shallowly equal. So let's go into the list. The list is this. I get all the values from the list and I check for something that will have all the keys, an equal number of keys, and that the values match by equality. So this is going to be shallow equality.
So you go through each.
Yeah, I keep a list of objects in my pool, and I'm differentiating by type. It's either array or object, because I want to have as many beans as I can to make things faster when looking it up. Because I'm passing over the list to find an object. In fact, interning can be kind of slow.
Yeah, so you're looking through each. Yeah, especially as it grows, right?
Mm-hmm.
You may want to have like multiple instances of intern, like, you know, as separate pools.
Yeah.
Because so you have these values, yeah. Sorry, wait, the pool type, where do you initialize that? Intern.pool.
It's here. And the types here will make more sense when I get to the next part. But you can think of them for now as like a list. And I iterate over the list of all the arrays that I have ever seen being interned. And I find the one that matches by doing equality on each value. There is more stuff around, but in essence, I have a list of every array that has ever been seen, and I checked doing shallow equality. I just look at the literal values of each of the two arrays and see if they match.
I see the weak ref.
That's the part that I didn't know about. Because if you do like I described, then every array that has ever existed in your program will live forever in memory.
Yeah.
The garbage collector will not be able to get them because your pool is still referencing them.
Yeah.
So to make this work with the garbage collector, I learned about weak refs, which are a wrapper, a box, that you can put anything in, and you can take the thing out again, but that box is not holding what is called a strong reference. So the garbage collector is allowed to garbage collect your value. So you put the thing in the box, and if there are other references to the thing, you are guaranteed to be able to get the thing out of the box. But if the only reference in the program to the contents of the box is the box, the weak ref, then the garbage collector may get the thing and collect it. So you would look in the box and now there is nothing there.
Yeah.
It may not.
Yeah.
I mean, it's up to the discretion of the garbage collection. The garbage collector may say, I don't want to do garbage collection now. And you look in the box and your value is still there. Hooray. But it may be the case that the garbage collector gets the thing and then you look in the box, it's undefined. And then you have to check. So when you deref stuff out of the box, you have to check, is it undefined? Has it been garbage collected?
That makes sense.
And if you do this, then you end up with less garbage. But you still end up with, let's say, garbage in the pool. Because it is the case that the pool is now has a list of a bunch of empty boxes, a bunch of weak refs that have been garbage collected. And that's annoying because when you're interning a new value, you will have to compare against a bunch of empty boxes, which is unnecessary work. Ideally, we would be able to pull out from the pool when the thing is garbage collected. And when I saw this problem initially, I thought, aha, I know. I'm going to use not weak refs, but I'm going to use a weak set, which is exactly what it described, but a set, a data structure. And I will use a weak set instead of a list. But haha, the weak sets and the weak maps are not iterable. You can not ask a weak set, what are all the values inside? You can ask for containment. So if you have a set and you have a value, you can ask, is my value in the set? And that's going to give you an honest answer. But you cannot ask the set, please enumerate what are all the values you have. So that's not going to fly. So what I did instead is I did a map, not a weak map, a map containing all the values, and the keys to this map are symbols. Symbol is another thing in JavaScript that I knew about, I have never used before. So every time that I am, it's a cache miss, so it's a new value that I'm interning, this is the code that is going to do that, I create a new symbol. A symbol is guaranteed to be unique. So this is a new key that has never been seen and it will never be seen again in the JavaScript runtime. The key of my map is this key, and the value is the weak ref with the value that I wanted to wrap. And then I use the next thing that I didn't know about. It's called the finalization registry. This is a piece of code that will run when your value is garbage collected. So I have my finalization registry and I register my value. So when the value is garbage collected, then it will run the function in the finalization registry, which is to go into the pool and delete that key.
Wow, that's very clever.
Isn't it? I thought it was super cool. And
that's really cool. I hadn't heard of finalization registry. I guess this won't be supported in all browsers, but
the finalization registry is supported in all browsers, yes.
Really? Okay, wow.
Yeah.
Because I hadn't even heard of that. That's really cool. Well, I'm sure it works in the latest Chrome.
No, it has been around for like a little while. It is not something that has been there forever.
Okay.
But it's not new either.
Right. Okay.
Yeah, in Chrome it has been for 3 years there. 2.5, let's say.
Oh, okay.
No, 3.5. Oh, I don't know maths. Yeah, so it's fairly well supported.
Oh, but it's not an IE, so
Yeah, true. And it's not something that you can polyfill.
does Safari support it?
Yeah. Safari was on that table.
Okay.
Safari in iOS
I'm sure it was,
since 2021. But it's also not the end of the world, because if the finalization registry doesn't kick in, you are going to make things slow, but everything is going to work. And
Yeah. Well, won't it throw in this code?
in this version, yes, you would need to check for the presence of the finalization registry and then instantiate it or not and all of that. But I'm not bothering with any of that.
Yeah.
And I also freeze the object, and I also experimented. So yeah, okay. So here's the story. I implemented this whole thing, but I didn't use a notion of shallow equality. I used the notion of deep equality. In fact, I used the Lodash is equal function. And then I implemented Advent of Code 23 using that. And it was too slow. I needed to compare objects by values, so doing the interning, for traversing the maze. And that was too slow because I was looking into too deep into things. So I re-implemented this using shallow equality, which was fast enough. And then the code runs in reasonable time. It's not instantaneous. I think that yours is much faster, but it is reasonable. It runs in reasonable time. And
I think mine was pretty slow. So yeah, that is interesting. I do have a bunch of comments, I suppose.
yeah.
I guess. Yeah. So I mean, first of all, it's really cool the way you did it with this like finalization registry and pool and like removing it. Even to think of that, I wouldn't have thought of how to do that. So that's really cool. And interesting that you're adding an internal symbol to it. Do you need that?
Well, that is
On
because
269.
I wanted to make sure that you would not be able to do something like this, where you intern. I again use the $sign to mean interning an array. And I don't want you to be able to intern an array that contains an object that has not been interned. Because if you do that, then you may modify this internal object, and then your interned value is modified as well as a side effect. It's a whole mess. So I wanted to make sure that this was the case. I wanted to make sure that if you have an object within an interned array, that object itself has been interned. And to do that, I mark all the objects that have been interned with this symbol.
Yeah, that's really smart. I guess you could also you could set it as a non-iterable property, so that when somebody iterates that value, they don't have like this random symbol coming up as well.
I thought about doing that because it was starting to annoy me when I printed my data structures. There was this symbol everywhere. But then I thought, maybe this is useful to mark this as not your usual data structure. It is special in that way. So I left it there, but I thought about it. Yeah.
Yeah. Okay. Yeah, that's really smart. And what's this? Why are you checking if the inner value, the type there? I'm just reading that now.
Yeah, that's the check that I was talking about. I want to make sure that when you're interning something, that it's either a primitive
or I see.
Or
I
it's
see.
null, which is an object. If you ask in JavaScript what is the type of null, it's going to say object. And null happens to be equal to null. So that's a special case. And otherwise, it has been interned. It has that symbol.
Yeah. That's fine. That makes sense.
Also, I made the types correct. So if you try to intern things that are not mutable, so for instance, coming back to the example in the documentation, this example, it fails to compile. This annotation is saying to TypeScript, you should find an error here.
Yeah.
Which I think is really cool.
Oh, that's pretty nice. Yeah.
I could even perhaps remove these lines because they are doing a runtime check, which is expensive to do.
Yeah.
It's doing a runtime check that is also done by the type system. But I left it for now because I was implementing day 23 in JavaScript, not TypeScript.
That makes sense. That makes sense. Well, you can always do check JS true. Okay, so I have a few other comments apart from it being excellent. One of them is, I guess you may not want it to be garbage collected or dereferenced because you don't have. I know you don't have control over that. If you're thinking about it, like this is a global cache for the whole application, then it's hard to know really. But coming back to what I said earlier, you may want to have like an instance, like say their coordinates. You may want to like create a pool of coordinates, and then with coordinates you can discard the pool itself altogether, right? Rather than having like, it might be advantageous instead of like letting these coordinates be dereferenced and deallocated and reallocated all the time. You might just want to keep the pool available.
Yeah, I left the pool visible to you as the user of this function so that if you want to do that, you can. By the end of the code, that if you know, okay, I can discard my pool, no harm done, you can say intern pool tuple dot clear. Intern pool record dot clear.
Like, yeah, I guess you could expose like reset or something like that.
Maybe, yeah. I could make this more convenient, especially because the pool right now, it's just separating tuples and records or arrays and objects, but it could separate, for instance, by size. What is the size of the tuple? What is the size of the record? And then the bins become smaller and the efficiency goes up, but
yeah,
it would be harder to reset. So maybe I could expose that, yeah.
So the way that I did this, I'm trying to look for my implementation, but I don't have it right now. But the way that I did it is I instead had a function called memo, short for memoize, and it would accept an arbitrary number of. You would define the arguments, and then you would define the function which you're memoizing, which generally would be to just construct the object. So if it was an array, it would just accept an arbitrary number of items and then output the result. And basically, for each argument would be like a tree would be like a level in a tree. So you would go through the map and you would work out, is this subtree here? So you start with the first argument, then the second argument, then the third argument, then the fourth. So you're accessing each level in the tree. And then you have to, obviously you need to need to keep track of that tree and prune things and whatever. But the leaf is the actual constructed final result of the function, if you see what I mean.
Mm-hmm. Yeah, in the way that you are explaining it, it seems to me as though the data structure looks different. When I print an intern value, it looks like a JavaScript object. In the developer tools in the browser, it will show up as a JavaScript object. Because it's just a JavaScript object that has been frozen and has a special key. But other than that, you cannot observe anything different about it. And in your version, it is a different kind of data structure. You're representing things in a different way.
Not quite. So, well, if you can invite me to this, Coach, I actually have to go pretty soon because I have to go to the dentist. But it's more that instead I took it to be just a generic memoization function, which has an internal cache. You define this memoization function, which you wrap in memo, and it basically, based on the arguments, if it sees those exact arguments again, then it can simply, it will just return the result that it's already computed. So it might just be outputting true or false, right? or it might be constructing an object,
I see.
and those objects are stored in the cache. And it's just the I was just describing the data structure of the cache, which is like a n level deep map, where each level is the arity of the argument, to use a fancy word which I can never remember. But you see what I mean?
You are making this data structure smarter than I did.
Yeah, so the advantage of that is that I guess the construction is a lot quicker, because you just step through each you're just looking up in a map, right? Rather than like shallow comparing all of the arrays. You can just go, I guess maybe not, maybe you will exit just as early. Well, no, because you're looking it up in the map rather than comparing it. You don't have to traverse every single cache item every time you create a new object. Instead, you check if that exact cache item is in your cache. So you go through each. So say it's a record with keys A, B, and C. In yours, you have to check every single record that exists. Is this one ABC? Is this one ABC? And in my implementation, you would go into the cache, you say, okay, is there a record where the first value A is this? Is there a record where the second value B is? You see what I mean?
Yeah, and this is smart. I mean, even copy your idea yet again.
Yeah, that'd be great. That would be great. We should do it together. So let me look at the testing. Because you could still do everything else that you have done here, and I do think that having instances, it's nice to have just a generic global instance, but it would also be nice to have a bit more control over that, so you can create an instance. I think that would be a nice addition. I really like the abstraction that you've thought about, to have, like, if you want to put an object in here, you must wrap it, kind of thing. It must be already interned.
Well, that is not actually 100% my own design, because all of this that I did hopefully will be obsolete in some time, because there is a proposal to extend the language with tuples and records, which are exactly all that I described. The shallow equality, the fact that you can do triple equals on the results. The only difference is that instead of writing it this way,
you write it with a hash or something?
Yeah, that. So my hope,
I guess,
is that one day I will be able to simply replace my dollar with a hash and remove the parentheses, and my code will work with the new feature.
I think maybe use more than just a dollar symbol, because it's going to be hard to replace that. Maybe use $3 symbols or something. But yeah, that's really nice. That's really clever. I guess what you could do now is just implement this as a Babel plugin.
There is already a polyfill with.
Oh yeah.
There is already a Babel plugin for the proposal. Usually proposals include some sort of plugin, and it's stage 2 right now. And there is a polyfill. The only reason I didn't go with the polyfill is that the polyfill kind of requires you to differentiate between. You either use the Babel plugin, which comes with its own sort of issues, especially in a stage 2 specification that is still changing. So you don't want to write things that are more serious than experiments. You could argue that Advent of Code is experimental, but anyway. Or if you don't want to use the Babel plugin and you just want to use the polyfill, then you have to be specific. So this, for instance, turns into like that. And I didn't like that you had to do this transformation. I wanted to just have a little bit of punctuation, like in the final version there will be, hopefully. I really hope that this goes through. I really want to see pattern matching, and I want to see tuples and records.
Yeah, that'll make a huge difference. Absolutely. Yeah, brilliant. So these tests, you literally just you just run the file, don't you? Yeah, I can see this. I've done testing like this before. I quite like this way of testing things.
Yeah, it's the node testing thing. It's great.
Oh, is this Oh, is this a new Node testing? I haven't used it
Oh yeah,
before.
it
Nice.
is part of Node now. It is under here.
Oh, lovely.
Test runner. All you gotta do
Ah.
is say Node tests or something like that.
Oh, great. Would this work with? Does this work with TypeScript? How do you run it with TypeScript?
I compile the TypeScript and then I run.
Mhm. Does it work just out of the box if you try with TSM? Or I guess you probably didn't try.
I don't know. I TSC, so in my tests I run prepare, which runs TSC, and then I node test. And I also documentation. Documentation is the name of the package that does the extraction from JS docs into the README.
Yeah. Yeah, very, very nice. Very cool.
All right. I think we can wrap up.
We can, yeah.
And you can go to your dentist. But yeah, this is the end of Advent of Code. I learned about stuff in Node.js. I learned about this interning thing. I learned about how to use worker threads. I learned about the whole garbage collection thing that we talked about. I even learned about like symbolic computation, and there are other libraries that do this besides Z3. There are even implementations of something that looks like SymPy in JavaScript. I brushed up on Dijkstra's and A-stars and all of those algorithms on graphs. And
Yeah.
it was a great time. Thank you very much for coming up with the idea of doing this.
This was, yeah, I learned so much. I'm trying to think about all the things that I learned. But yeah, it was really cool. I also really enjoyed coding with you because it was interesting to see your style. And I think I have a lot to learn from your way of doing things. It was really interesting. I think you do try and very hard to make things radically straightforward. So it's very on brand, and I like that. And I also think, what else did? Yeah, there's a lot of concepts that I'd forgotten, or yeah, certainly hadn't written graph algorithms in a while. So that was good fun.
Yeah, I learned a lot from your coding style as well, from the way that you use the tools, like the way that you, for instance, use Copilot, and also some like brilliant ideas like, let's just memorize this function, and then what took days, and it was probably not gonna finish, took seconds or not even that. So some brilliant ideas in there.
Yeah, from you too. All right, well, I don't know if I will have the energy to do this next year, but it was I can't think about that right now, but it was great fun.
Yes, and we will do some other things together in the near future. We can work with some of your ideas that you mentioned, and some other coding challenge and stuff like that. There is the full bar coding challenge from Google that we are still working on. So lots more to come. All right, so thank you very much, David. Thank you to everyone here on the chat. Bo, Nod was one, Fochis, Binayam, I think that's how you pronounce this username. And I'll see you on the next one. Bye.
See you soon, Leandro. Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.